You know, in some sense, the opposite, if you will, of direct variation is inverse variation. That's when we have the x and the y fitting together to conform to this particular function. Y equals a constant divided by x. So it's called inverse variation because if you think about it for a second, if we think of the constant here as being some, let's say, positive number just for the moment, as the x's get bigger and bigger and bigger, what happens to the y's? Well, think about it. If the denominator is getting larger and larger and larger, and we have this constant on top, then the y's are actually getting smaller and smaller and smaller. So as the x's go up, the y's go down. That's why it's called inverse variation. Direct variation, remember, is one where, if k is positive, as the x's go up, the y's go up correspondingly. But here with inverse variation, what we see is as the x's go up, the y's go down, and inversely, as the x's go down, the y's will go up. That's why they're called inverse variation. You can see that by looking at this particular function. So let's take a look at an example. So given that y varies inversely as x, that alone tells us this is the function. This is the function. We don't know k. We don't know k. But we know it looks like that. And, incoming information, y equals 2 when x equals 6. Well, that information is going to allow us to figure out what k is. Anyway, now our mission is to write and graph the inverse variation function. No problem. Because you see, once I know it's inverse variation, I know it looks like this. Once I am given 2 points, y equals 2 when x equals 6, I can find k, that special constant. Remember, k is not a variable, it's just an unknown constant. So I see that 2 for y will give me 6 for x, and I can multiply both sides by 6, and I see that k equals 12. And so therefore, y equals 12 over x. That is the inverse variation in this case. Okay, great. That was pretty easy. And now we want to graph it. Well, how would you graph this function? Well, there are lots of ways of graphing it. You can plot a little table of points here real fast. So if you plug in, for example, negative 6 for x, you see 12 divided by negative 6, that's negative 2 for y. 12 divided by negative 4 is negative 3. 12 divided by negative 3 is negative 4. 12 divided by negative 2 is negative 6. And then we get the similar type of values here for the positive ones. And now we can plot away. Love the plot. You gotta love the plot. That's sort of funny. Next time, like you're reading a play, and they say, what's the plot? You can say, well, I don't know. Where's the table of values? And you can. All right. Negative 6, comma negative 2. So negative 6, comma negative 2. Put a point there. Negative 4, comma negative 3. Negative 3, comma negative 4. Negative 3, comma negative 4. Negative 2, comma negative 6. Negative 4, negative 5, negative 6. Then we do a jump here to 2. 2, comma 6. 3, comma 4. 4, comma 3. 6, comma 2. So what does it look like? Well, notice that they sort of, part of it's here and part of it's here. Notice that we seem to never cross the the x equals 0 line. Does that make sense? Sure, look at this thing. You can't have x equals 0 because you can't have 0 in the denominator. So in fact, we have what's called an asymptote. And then the functions drop heading toward the x-axis, namely heading toward a height of y equals 0. And we get this curve that's called actually a hyperbola. And you can see it has 2 pretty wings. And in fact, that represents a generic picture of what inverse variation looks like. Here it is algebraically, here it is graphically, and what it means is that as x's go up, in some sense, y's go down.